Let's take a look at another chapter, more specifically magnetic field patterns chapter, or the chapter on magnetism. This can be found in IGCSE chapter 4 and SPM Form 5 chapter 3. Before we continue, you will need to know a few things. First off, you will need to know your right hand rule. Okay, remember from our notes, this right hand rule here. Okay, recall that your thumb represents the direction of the current. Okay, this is an electromagnet, not a permanent magnet, so we're going to pass a current through a conductor, and your thumb represents the direction of the current, right? Positive, in this case positive to negative, so your thumb points from positive to negative, and your four fingers represents the curl or the direction of the magnetic field. You need to know, familiar with this rule, this right hand rule, before you can actually start to do the worksheet. Using the right hand rule, let's try to do some questions. Okay, so remember there are three potential questions in drawing electromagnetic field patterns. First one is a wire. Okay, it's a straight wire and you poke it through a cardboard. The second one is a straight wire, you poke it through the cardboard on the left hand side and you reverse it and poke it on the right hand side, so it becomes a coil. Remember, a coil, if you have several coils, okay, and you add them together, it just becomes a solenoid. Alright, so basically coil, solenoid, they all start off with one single wire. So okay, let's try using our right hand rule. Okay, right hand rule is this one here. The thumb, your thumb represents the direction of the current, and the four fingers represents the direction of your magnetic field that you want to draw. So in this case, let me zoom in. Your cardboard, the arrow represents the direction of the current. It's pointing here. So using your right hand rule, your thumb would be pointing on the right hand side. So four fingers curl, right hand, it only works on your right hand, not your left hand. So if you do it correctly, you'll notice that it goes like this. Okay, easy. Let's try for the coil now. Okay, so for the coil, okay, your current is going up. You have to imagine this cable here, the current is going up, and on the right hand side the current is going down. So if I were to use my right hand thumb, it will look like this, and on the right hand side it will look like this. My thumb, this is my thumb pointing up and pointing down. So if I were to draw my curls, magnetic field lines, okay, remember it's closer towards the center. The field lines are stronger as you go towards the closer to the source, so you draw it closer together, and as it goes further and further away from the source, the lines get spread out more. So same thing right hand side. So this part here, 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 here. Okay, of course, yeah, this is just a vector, so we can add magnetic field lines and it just forms a straight line here. Before we try this question, I think I prefer to use the bottom part of this question here. Okay, so basically it's easier to see, but basically they are the same thing. In fact, question 1 and question 2, hint is the same thing. The first one here corresponds to this one dot here. The second one corresponds to the dot and X, and the final one is the dot and 6 dots and 6x. They're actually the same thing. The difference is that this is 3D view and this is a 2D view. So this is, if you look at this one here, the third one, you're actually viewing from the top here. Your eyes are actually viewing from the top, so you actually look at it. The coils actually look like this. Okay, so I'm sure I've said it in class before. The annotation, what does a dot and X represent? So the dot here, this annotation is actually representing the arrow. So imagine someone shot an arrow at you. Okay, what you see before you invariably get impaled by the arrow head is this black dot here. And if you were the guy shooting at your friend, the last thing before it hits your friend is that you see the arrow's backside, which looks the feather, the whatever, the fletchering or whatever you call it. It looks like an X. So basically, when you see this on the left hand side, the dot, it means that the current is coming out of the page. right? It's coming up, it's coming out of the page, and on the right hand side, the current is going into the page. Okay, the arrow is the imagine the arrow flying further and further from you on the right hand side, and the arrow flying towards you on the left hand side. Okay, to start doing this question, first off, you will need to use, again, it's actually very easy to do. Just use your right hand rule again. Okay, just use your right hand rule for each of the circles or each of the dots. So your thumb in this case is pointing out of the page. Okay, it's pointing out of the page for the left hand side. Since the arrow is coming towards you, the current is coming towards you. So right hand side arrow. Okay, left hand side arrow is going, your thumb is going to point down into your page. Okay, into your screen. So into your screen, all right. Okay, it's going to look like this. So likewise, I can repeat the same things over here. Okay, I can repeat it. It's getting messy. All right, I can repeat it over and over again. Same thing, left hand side, I can repeat it over and over and over and over again. Okay, so yeah, I'm getting lazy to draw the extra circles because it's getting messier and messier. So what's going to happen is that you're going to combine all of them. Okay, remember, magnetic fields are vectors. If they point in the same direction, the arrows get bigger or longer. If they point in the opposite direction, the arrows cancel out each other. In this case, the arrows are all pointing in the same direction, so you can actually combine them into one larger one. All right, let me change the color. One larger one, especially the outside one. It becomes one larger one or two larger ones, and they follow in this direction here. Okay, right hand side similar, one larger ones, and like that, and it goes like this. Okay, so if I were to combine a magnetic field, it looks like this. Okay, the antenna. Okay, it looks like this. So this would be your North Pole and this would be your South Pole. So coming back to this question, it's just a simple, what I'm going to do is I'm just going to simply draw it like this. So okay, and the other side would be like this. Okay, if you look at a permanent magnetic field, they're actually the same thing, right? The north to south, the arrow looks like this. Alright, so we actually created a temporary magnet that has the similar properties as a permanent magnet.